Alright, so we are busy with the Mathematics Higher Level Paper 2, Khomas region for August 2020. Again, we've already covered quite a few questions here. We are today on question 6, and we'll probably do 6 and 7 today. Alright, so we are told the length, x meters, of a green anaconda snake, which is 2 years old, is given by the approximately by the formula x equals 0.7 times the square root of 2t minus 1. And t only runs from 1 to 10. Using this formula, find the derivative of x with respect to t. So the first thing I'm going to do is just rewrite this equation. I'm going to say x equals 0.7, and then instead of the square root, I'm going to write 2t minus 1 and write it in exponential form. So 2t minus 1 raised to the half power. Okay, so once we have this, now we've got it in polynomial form, so we can find the derivative. So we want to differentiate x with respect to t, and we'll use the chain rule formula. So chain rule says we take the exponent here and multiply it by the coefficient in front. So a half times 0.7 is 0.35. And then we just rewrite this whole bracket and subtract 1 from the exponent. So half minus 1 is negative a half. And then we multiply, because it's the chain rule, by the derivative of the bracket. So the derivative of 2t minus 1, if we differentiate that, we just get 2t becomes 2, and negative 1 just falls away. So we just times it by 2. Okay, let me just get rid of that. And now we can simplify a little bit. So 2 times 0.35 is 0.7. And this part here, 2t minus 1 to the negative a half, we can't have a negative exponent on our answer. So we're going to move that to the bottom and have 2t minus 1. And then the sign will change to a positive. And that is our answer. So let's move that to the answer block here. So that is our answer. And you could have also written it as 0.7 over the square root of 2t minus 1. That would also be fine. Minus 1. So either of these two would be correct. Alright. Now we're going to find the rate of growth of a green anaconda snake, which is 5 years old. So the rate of growth. So this tells us the actual length. Now the rate at which that length is changing, which is the rate of growth, is the derivative. So the rate of change of anything is when we differentiate it. So we've already differentiated. So now we can just find that. So we're going to say the derivative at 5 is equal to, and then we're just going to use that formula. I'll just use this one at the top here. So 0.7 over the square root of 2, and t we now know is 5 minus 1. And we can just calculate that. So that's 0.7 over the square root of 2 times 5 is 10, minus 1 is 9. So that gives us 0.7 over 3. Okay, and as we saw in the instructions, we have to round off to 3 significant figures. So let's just check on our calculator. Let me open a calculator here and see what that gives us. The 0.7 divided by 3 is 0.23 recurring. So round that off to 3 significant figures. That would be at this part, so it's 0.233. 0.233. All right. Then we get to question 7. So the second term of a geometric progression. Okay, so this is sequences in series. And yeah, let's continue with this color, that's fine. The second term of a GP, so term 2 of a GP is 3. But we also know a GP has the formula of AR. Let me just write that on the side here. For GP, we've got the nth term is AR to the power n minus 1, where A is our first term, and R is our common ratio. Common ratio. Okay. So we can use this formula. So just replace the n with a 2. This is equal to AR 2 minus 1. So simplifying this, we get 3 equals AR. This 2 minus 1 is just 1. R to the power 1 is just R. So here we have one equation. Alright, now let's find another one. Let's say the sum to infinity is 12. Okay, so sum to infinity of a GP is A over 1 minus R. Okay, so we can say that here. So sum to infinity, sum to infinity equals 12. but we know that's the same as a over 1 minus r. Okay, so here we have a second formula, a second equation. And now we can solve these two simultaneously. So I'll probably, let's say we want to get a by itself. So in this one, if we're going to get a by itself, we just divide both sides by r, and we get 3 over r is equal to a. And now we can substitute this into that equation. So we have 12 equals, and instead of a, we're going to put 3 over r over 1 minus r. So now r is our only unknown, and we can solve for that. So let's multiply both sides by the denominator. So we'll get 12 times 1 minus r equals 3 over r. Let's multiply this out. So we get 12 minus 12r equals 3 over r. Let's multiply both sides again by the denominator. So that's r. 12 times r is 12r. 12r times r is 12r squared. And 3 over r times r is just 3. Okay, so we see we have a quadratic trinomial here. So I'm just going to put 0 on this side and take everything else over. So that becomes positive 12r squared minus 12r plus 3. Ah, what a bargain. We can still take out a common factor, so we can divide everything by 3. So 0 equals 4r squared minus 4r plus 1. Now this will just make it a little bit easier to work with. So I think this one can factorize. Let's quickly check. Yes, that should be able to factorize. So we're going to do 2r minus 1 and 2r minus 1. So 2r times 2r is 4r squared. 2r times negative 1 is negative 2r, minus another 2r is negative 4r, and negative 1 times negative 1 is positive 1. Great. So we know r is equal to, take the 1 over and divide it by 2. So r is 1 over 2, and the same for this one, so we can just use that part. Alright, so we are asked to find the first term, so that'll be a. So what we can do is we take this equation and just substitute the r that we've already found into that. So 3 over r, which is a half, equals a. Now 3 divided by a half is 6. So there we go. 6 is our first term. Yeah, quite a bit of work, but like we say, it doesn't take that long to do, so it's still fine. As we get given probably about 1.2 minutes per mark. So we should be able to have this in 4 times 12, 4.8 minutes, 5 minutes to complete this question. And I think we took less than that, so that's fine. Alright, now an arithmetic progression has the same first term and second terms as the GP. Okay, so we know the first term is 6 and the second term is 3. They've given that to us because they told us term 2 is 3 and we found term 1 is 6. So these are the first two terms of our GP. Arithmetic progression, right? AP. So first term 6, second term 3, and since we know it's an AP, we can just say this will be the common difference will be negative 3 minus 6, right? So we have a equals 6, and we've got our common difference equals negative 3. So we have to find the sum of the first 20 terms. So how do we find the sum of the first n terms of an AP? Well, that'll be Sn equals n over 2 times 2a plus n minus 1 times d. Okay, so this is a generalization of a formula that was invented or discovered, however you want to see it, by an 8-year-old kid called Carl Friedrich Gauss, nicknamed the Prince of Mathematics. And maybe in another video or in some other videos in the channel, we'll go through where this formula comes from and how to prove that this is in fact the case. But that's a good story. You can go read it. It's a very interesting story. Alright, so we have to find the sum of the first 20 terms, so we can do S20. So S20 would be 20 over 2 times a, and we know a is 6, plus n minus 1. We know n is 20, so it's 20 minus 1. Common difference we found is negative 3. Okay, and now this, we can just type all this in the calculator, but for a bit of practice, I'm just going to do this as head calculations. 20 over 2 is 10. 2 times 6 is 12, plus 19 times negative 3 is negative 57. So that will give us 12 minus 57 is negative 45. So we get negative 450. So that is the sum of our first 20 terms of this AP. Okay, if you used any other methods to find out this answer, please let me know in the comments below and we can have a look at that. Good. Question B. Evaluate. So this is going to be an interesting part that some people don't think about in this question. I think that's specifically there for a bit of a tricky extension to the question. Okay, evaluate the sum from n equals 4 to 17 of 3 to the power n minus 2. Now for me the easiest way to do these questions, or at least the safest way, is write down the first three terms by substituting 4 and then 5 and then 6 as they give here, and then check is that an AP or a GP, and then from there we know how to find the sums, right? Okay, so term 1 in this case will be when we substitute 4 into n. So 3 to the power 4 minus 2, which gives us 3 to the power 2, which is 9. Right, so that's term 1. Term 2, we're going to say that's 3 to the power 5 minus 2. And that is 3 to the power 3, which is 27. And for term 3, we have 3 to the power 6 minus 2, which is 3 to the power 4, and that's 81. So these are our first three terms. Okay, so we can see we've got a common ratio. We're multiplying by 3 each time. So that's good. So now we have all the information we need. We've got A equals 9, the first term, and our common ratio equals 3. Perfect. Okay, now we need to find the sum. So the sum formula for GP is Sn equals A times R to the power n minus 1 over R minus 1. And you could also swap it around. You could also have A 1 minus R to the power n over 1 minus R. These two equations are equivalent, so you can use either one, it doesn't matter. I know some textbooks say use one when the R is greater than 1, use the other one when it's between 0 and 1 or something like that. It really doesn't matter. It really doesn't matter. You can use whichever one you like. Okay, so here is our equation, and now this. So this is the number of terms that we're adding. So in this case, how will we know what that is? It won't be just 17, it will be the difference. To find out how many terms it is, so if you're starting at 4 and ending at 17, how many is that? That would be, so let's say this n here, that would be the top value minus the bottom value, 4. So 17 minus the 4 plus 1. So this plus 1 is a little thing that people sometimes forget. So if we're saying from terms 1 to 3, that means term 1, term 2, and term 3. So we'll have 3 values, right? So if we just say 3 minus 1, we'd get 2, which is not correct. So that's why we say 3 minus 1 plus 1. So top minus bottom plus 1. So this will give us 13 plus 1, 14. So what that means in essence is we have to find S14. Okay, so S14, and we just plug it into this formula. So A is our first term, which is 9. And then we've got R, our ratio, which is 3 to the power n, which is 14, minus 1 over R minus 1. And again, we can just type all that in our calculator, and I will probably do that. So here we've got, I'm just going to simplify this a little bit, so that's already a 2, so I'm just going to write 9 over 2, and then 3 to the power 14 minus 1, which is a little bit too big for me to do in my head, so that's where the calculator comes in. Alright, so we've got, I'm just going to do the bracket part first, 3 to the power 14 minus 1. Okay, so that gives us that whole thing. And so that's at the moment it's, let me just copy that. Copy and paste. Okay, so that is the value of the bracket. So we're going to say that times 9 divided by 2. Okay, so that value times 9 divided by 2 equals 215. I'm going to copy this again. There we go. So let's just write that on 215, 2, 3, 3, 5, 6. Good. Okay, that was it for question 6 and 7. Then we'll do question 8 shortly.